Yes.
Yes, miss.
Okay, great. Thanks. So this was one of the questions that we looked at last week, and you know, when I introduced you to the quadratic expression, and just for the purposes of review, I'm just going to go over how we do the factorization, right? So we said that we need two numbers that when you multiply them, you get the product of A. A is a coefficient of x squared, and C, right? So you should say A times C gives you, in this case, A is 1 times 21. So you need two numbers. When you multiply them, you get 21. And when you add them, you get negative 10. You get negative 10. Last week we had agreed that the two numbers are negative 7 and negative 3, because negative 7 times negative 3 gives you positive 21. And if you add negative 7 and you add negative 3 together, sorry, this is supposed to be 3, you get negative 10. So then we go ahead and we rewrite the equation to say x squared, but instead of using the middle term, we now use the two numbers that we got, which were negative 7x and minus 3x plus 21. So then we would go ahead and factorize as per usual. So we had said that when we have, you know, four terms to factorize, we factorize by pairs. So we factorize the first pair and then the second pair to end up with two brackets. So in this instance, the highest common factor would be what? What would be the factor for the first pair?
For the first, for x.
X. So x into x squared
Equals x.
Gives you x, and x into minus 7x gives you minus 7. And then for the second bracket, what's the highest common factor?
3 plus 3.
Plus 3?
Plus
You
3.
sure? You want to use plus 3?
Remember, times
all right. So remember we said, I'm not hearing you so clearly. You're a little bit low. I'm wondering if it's my thing low, or you want to speak up a little bit so I can hear you. All right. So remember last week we had said that both brackets need to be the same.
Yes.
Right. So if you use plus 3, you're going to end up with, so let's use plus 3 to show you. If you use plus 3 into negative 3x gives you what? Positive 3 into negative 3x gives you what?
What's that? X? No, we are negative.
Not just x. You have to give me the sign. You're going to give you negative x.
Yes.
And then plus 3 into positive 21 gives you what?
Oh, yes. I see
3 into 21 gives you positive 7. So we're seeing that the brackets are not the same. The signs are not the same. So what that means is that you need to factor out the negative sign. So
yes.
So factor out the negative sign.
So you have negative 3.
So you have negative 3x, and then you would say negative 3 into negative 3x gives you x.
Minus 7.
And then you will have minus 7 here. Excellent. So always bear that in mind. While positive 3 can be used, bear in mind that both brackets need to have have
the same signs.
Need to have the exact same thing. So this is minus 7. And then we go ahead and factorize. So we have x minus 7 in one bracket, and the next bracket is x minus 3. All right. So this here that we have, up here we call it an expression. Anybody can tell me why we call it an expression and not an equation?
Because it oh, step up on
Huh?
it.
Huh?
Uh,
Anybody can tell me why we call this an expression? Because we call this an expression and not an equation. Why?
because once you work the equation, you end up with that would basically be like the answer. Once you work the equation, you'll end up with that part of it.
So this part that I circle in red, that's what I'm talking. That is what they call an expression. They don't call it an equation, they call it an expression. So I'm asking you why they call it an expression.
Because it is factorized, or
Because it is factorial. All right. So when we talk about an equation, right? An equation usually have one characteristic. It's equal to something. Yes? So equations are equal to something. If it doesn't have an equal sign, it's an expression. All right? So all you've been working so far are expressions, not equations. Everybody following me so far?
okay.
So
Yes, sir.
you do the expressions effectively just to get an idea of how to apply the principle, etc., etc. And you may need to use it when you're working bigger questions, right?
Okay.
However, you also need to learn how to, I'm going to use the same question. You also need to learn how to work a quadratic equation. So quadratic equation usually takes the form that you see me have here, the one that I've written here. That's the form quadratic equation usually take. So you have your x squared, usually have a coefficient. In this case, our coefficient is 1 because there's nothing beside it. You have minus, you have an, you have another another term here, which is usually x plus another coefficient. In this case, that's minus 10 plus c, which is just a number. And it's equal to 0, right? So most times or all times, your quadratic equations would be equal to 0. And there's a reason for that. I'll show you a little later on. So your quadratic equations must be equal to 0. So if I'm going to be using this same thing right here, and instead of saying factorize the quadratic expression like we've been doing so far, it says solve the quadratic equation, you would attempt it the same way. So you say all of this that you work out right here, sir. Please tell me if you're following me now. You say all of this that you work out right here, sir.
Okay.
You would do it same way, right? I'm not going to rewrite it because we work it already, but you would do it same way, and but everything would be equal to 0, right? At every line you put equal to 0.
Okay.
So at the end of it, all right, you know what? Let me not shortcut it. Let me write it back so that you can see and understand. So you would do the same thing. You would split the term. You would split the term, so you'd have x squared minus 7x minus 3x plus 21. In this case, it's an equation, so it's equal to 0.
0.
Everybody following?
So far.
And
Yes, sir.
you would factorize as usual. You factorize this pair first, and then this pair, and you would get
0.
what you get the last time, x minus 7 minus 3 x minus 7, and that is equal to 0. Yes?
Okay.
Then the next line will be the same like we've been doing from last week, x minus 7, and in this line it will be x minus 3, but it is now equal to 0. Now, how would you solve this? Because you have two brackets. It's pretty simple, actually.
Which would you
So,
take one set over?
no. There's no taking a set over in this case. So
Okay.
before you do that though, what you need to do is you need to appreciate that. Trying to find a different
7.
color. You need to appreciate that both of these
Minus.
are actually solutions to the quadratic equation, right? So usually when you work an answer, when you work a question, an equation, you usually get one answer, yes?
Yes.
When you work in a quadratic equation, there are two possible answers. So each bracket represents two possible answers. So the next step would be to say
X minus
x
7 is
minus
equal
7
to
is equal to 0, and
X
you work out x minus 7 equal to
equal
0,
to
or
X equal to
x minus 3 is equal to 0. So both of the brackets represent possible solutions, and you work out both possible solutions. You following me so far?
Yes. This
yes.
is the step. This
So,
and this is the part where you now take over the numeral
yes,
to the side.
right. So you solve,
Okay. So x will
so you
become
solve it like normal now. So you just
okay.
say x equals to 7, because you take over negative 7
Yes.
and it becomes a positive 7.
Yes.
And for over here, so
X equals
x is a
Equal to E.
positive 3. Sorry, I have a plus sign. It should be minus. All right, so there we have it. So this would be the solution for this quadratic equation. So key things that I want you to remember. Quadratic equations are usually equal to 0. So if you ever get a quadratic equation to solve and it's not equal to 0, it simply means that you need to rearrange it so that it's equal to 0, right? You need to carry something across the equal sign for it to be equal to 0, because they're always equal to 0. The second thing is you factorize a quadratic equation like normal, and when you get the two brackets, both brackets represent two possible solutions for the quadratic equation. Everybody following me?
Miss, repeat
Yes.
what you just said. Miss, can you repeat the last line of what you just said?
I can. Just give me a moment. All right. So I was saying to you, when you go about solving a quadratic equation, two main things or three main things I want you to bear in mind. A quadratic equation is always equal to
Zero.
0.
Yes.
So if it's not equal to 0, it means you're going to have to do some work to get it to equal to 0. And I'll show you an example of that, right?
Okay.
The next thing I want you to realize is that you would factorize a quadratic equation like you've been doing. The only difference now is that it's equal to 0. So when you get the two brackets, those two brackets represent possible solutions to the quadratic equation. And because of that, both you will solve for both of them and you will get two answers. That
Okay.
is clear?
Yes. Okay.
Yes.
Clear? Great. So before I give you another question, um, before I give you another question, I just want you to appreciate why it is that a quadratic equation will yield two, two possible solutions. Now, this that I'm drawing here is how you would rule up a graph, right? It's a Cartesian plane. So I know you don't do this as yet, but I'm just going to refer to it when we do graph, coordinate geometry, it will become more clear to you, all right? So
Okay.
this is a Cartesian plane. That is how we plot, what we use to plot graphs, yes? So
Okay.
the one that runs from left to right is the x-axis, and the one from top to bottom is the y-axis. Now, if I were to plot my quadratic equation on a graph, it would do something like this. Everybody seeing that?
Okay. So make a U.
Yeah.
it would be a curve, right?
Okay.
But the curve is not what I want you to focus on so much right now. What I want you to appreciate is that if you plot it on a graph, it will cut the x-axis two places, and I'm circling the two places that it cuts the x-axis. Yes?
Okay.
You see those two places that it cuts the x-axis?
Yes,
Would give you these values right here.
Okay, so this 3 and 7.
So that is why, even though it seems weird to you that it has two solutions, that is the reason why it has two solutions. Because if you should plot it, it would look like this or similar to this on the graph, and it would cut the x-axis in two places that I've circled in red, and those places that it cut would actually be 7. In this case, it would be 7 and 3 on the y. You understand? That's why it have two solutions. Everybody following me?
Yes, me so far.
So I don't want you to get confused and funny about the two solutions thing. That is the backstory to the two solutions, all right? So just bear in mind that they will have two possible solutions, all right? So I'm going to go ahead. Any questions for me before I move on? Any questions? Everybody understand everything clear?
Good so far.
All right, great. So let's go again now. Let's do another one. So we're having x squared here. I think this is a little bit too big. So we're using x squared plus x equals to 20. So here we have something again. So the key thing about quadratic equations or expressions is that you have to know what it looks like, right? Remember when we started and I said quadratic expressions have the format a x squared plus x plus x plus c
plus a
plus
numeral
bx plus bx plus c, right? Now, as it is now, this don't really look like it, but you have to have that eye that when you see them like this, you know that if I should rearrange this equation, this will give me a quadratic equation, all right? So what you would need to do in this instance is you would need to carry this 20, you need to move from over this side of the equation
to the left
to
side.
over here, right? So we're going to
20.
rearrange, we are going to rearrange the equation and get x squared plus x, and now when it comes over, it's going to be minus 20. Nothing is left on this side of the equal sign, so it's going to be equal to 0. Following me?
Okay.
So far?
Yes, miss. So far.
All right, great. So again, you now have your quadratic equation. So you factorize a quadratic equation as per usual, just like you would normally do. You find the two numbers that when you multiply them, you get AC. In this case, A is 1 times C is negative 20. And then when you add them, you get the number in B, which is 1. So this is actually one that we did last week as an expression, a factorization expression. So I'm just going to put in the numbers. We did this last week already. I think the numbers that we got were 5 and negative 4.
Yeah.
Right. So 5 and negative 4. So we can go ahead and rewrite our equation to say 5, foolishness.
X squared.
Yeah, I don't know what happened to my brain.
X
so we're going to rewrite it to say x squared
plus 5
plus x.
Yes.
No,
plus 5.
Plus 5x,
5x,
yeah.
yes,
I hungry. Minus 4x,
4x minus 20.
Minus 20 equals to 0, because this is an equation now, right? So we have to make sure we keep our equal sign. And then now we go ahead and we factorize. So we factorize by pairs. This pair first, and then that pair. So again, this is something we did last week. So I think we would have ended up with, what is the factor for this one?
X plus 5, X minus 4.
What's the factor? Tell me the
The
factor first.
factors we had was 5 and 4.
The factor
For the first part, X. For
No,
the first
ma'am.
one is X.
X, yeah. X into X squared.
Because X,
X.
And then
5, plus 5,
what kind of 5?
plus
Plus
5,
5. All right, and then for this one now you have
minus
plus
4,
4.
minus 4,
X plus 5.
plus
X
5,
plus 5, and it
equals
is
0,
equal to
equals 0.
0. All right, so then now let's go ahead again. So one bracket will have X plus 5,
And one
the other one will have X minus 4, and it is equal to 0.
0.
Right, I'm gonna carry it up here. So all right, so we know that we have our two brackets, and as I said before, both brackets would be is our possible solution. So we're going to solve for both of them. So let's take the first one. Let's take X plus 5. So we will say X plus 5 equals 0, which means
and
X
then
is
X
equal
is
to
equal to minus 5.
negative 5, because it carried this 5 across the equal sign. And then the other solution is X minus 4 equals to
X
0.
is equal to 0.
0 plus
And then
X
X will be
equals
equal
4.
to
4.
positive 4, because you
Yes.
carry it across the equal sign. All right, so that would be the solution for that one. All right, everybody is comfortable so far. I see someone
Yes,
new. Somebody
Yes,
new is on. So I don't want to mash up nobody's name. Sanaja, are you understanding? I know you joined late. Are you understanding? Just let me know. Sanaja, sleep on me. All right. So everybody is okay. Everybody else, because Sanaja gone. Look like
Yes, miss.
she just
Good so far.
all right. Good so far. So let me give you, I'm going to give you 2 to do on your own, and then we will give you a couple minutes to do it, and then we can reconvene and work them out together. All right.
Okay.
Okay.
All right. So let's go. One, and then I'll give you X squared. All right, so please attempt those 2 for me. I'll give you a third one. So I'm giving you 3. So I'll give you about 12 minutes. That's what, 3, 4, 12, yeah, about 12 minutes. And then we'll come back together and work them out.